Hello everyone, myself I'm Dr. Lakshmi Soujanya. I'm working as an associate professor in the Department of Mathematics from Marri Reddy Institute of Technology and Management. In the previous session, we discussed how to solve the homogeneous system of equations. I'll just revise that concept, then I'll go to non-homogeneous system. So in homogeneous and non-homogeneous, first you have to take the matrix representation in the form of Ax equal to B. If this B value is equal to 0, then we can call the system as homogeneous. If this B is not equal to 0, then the system is called as non-homogeneous. So to solve homogeneous system of equations, that means first to solve Ax equal to 0 form, we followed three steps. The step 1 is the matrix representation for the given system of equations, that is Ax equal to B, and identify the values of A, X, B. In step 2, you have to calculate the rank of the matrix A. In step 3, you have to compare this rank value with the number of unknowns for the given system of equations. If this rank is less than, the system has if the rank is less than the number of unknowns, then the system has infinite number of solutions. If rank is equal to the number of unknowns, the system has unique solution or trivial solution or null solution. Now, for non-homogeneous system also, we are following the same procedure, but we have to add one more step to solve the system of equations. Non-homogeneous means here B must and should be non-zero. That means there exists at least one non-zero value in the column vector B. So here to solve the non-homogeneous system, I told you that we have to add one more step. That one more step is your augmented matrix. We have to define a new matrix of the form A given B, augmented matrix A given B, which is defined as we are simply adding the matrix B or the column vector B as the last column of your matrix A. See, in the previous explanation, I told you I am taking m equations with n unknowns, and I explained how we have to take A, X and B from that equations. See, this one is your A, the coefficient matrix. A11 to A1n, AM1 to AMN. This is a coefficient matrix, and this one is your matrix B. So I just added this matrix B or column vector B as the last column for the matrix A. This type of representation, this type of matrix is called as the augmented matrix and is represented as A given B. So to solve the non-homogeneous equations, definitely must and should you have to take the augmented matrix A given B. So instead of taking rank A, here we are calculating the rank for augmented matrix. That means we have to convert the augmented matrix to upper triangular form. That is the difference we are doing in homogeneous and non-homogeneous system of equations. Now here, from augmented matrix, we can say that using augmented matrix, if you are taking this augmented matrix, how many ranks we can calculate here for this total entire matrix? So if you are choosing the entire matrix A given B, for this matrix you can give one echelon form and you can take the rank of A given B. The entire matrix is augmented matrix A given B. Similarly, you can neglect this B column and you can take only the matrix up to A. Up to A means here also you will get upper triangular form. You can convert the lower diagonal values to 0. That means you can take rank of A also. So if these two ranks are equal, if both rank A given B is equal to rank of A, then the system is consistent. If it is not equal, then the system is inconsistent. So here for non-homogeneous system, the system is consistent if and only if the coefficient matrix A and the augmented matrix A given B has same ranks. If those are different, the system is inconsistent. So for non-homogeneous, definitely you will get consistency and inconsistency. In case of homogeneous, the system is always consistent. There is no B value, so we won't get that problem with A in homogeneous case. But mostly we will get the problem with non-homogeneous case only. In non-homogeneous, sometimes the system is inconsistent. Inconsistent means it doesn't have a solution. So when it is inconsistent, if both rank of A given B and rank of A are not equal. If both are equal, then the system is consistent. So in case of consistency, you have to find the solution, like how we have done the solution in homogeneous. Here also you have to solve the solution in non-homogeneous. So we'll follow the same procedure. But if both the ranks are equal and is equal to number of unknowns, then the system has a unique solution. If it is less than the number of unknowns, system has infinite solution. Okay. Inconsistency means ranks are not equal. The same points here I explained here. If both are equal, the system is consistent, and in consistency also again, if it is equal to number of unknowns, the system is unique solution. If it is less than the number of unknown, the system has infinite solution. If both are not equal, system is inconsistent. So to solve the non-homogeneous equations, you have to remember these three conditions. Now let us see one problem. Here I have taken some non-homogeneous system. So first write down the given equations. So the given equations are, your first equation is x plus y plus z equal to 6, x1 x minus y plus 2z equal to 5, 3x plus y plus z equal to 8. So to solve these equations, same steps like homogeneous. Here also your step 1 is, you have to take the matrix representation Ax equal to b, identify what is A, what is x and what is b. Next step 2, there in homogeneous system, in step 2 we calculated the rank of A. Now for non-homogeneous system, you have to take the augmented matrix A given B, and you have to calculate the rank of augmented matrix and rank of A. So what is step 2? Instead of taking single rank, here you have to define the augmented matrix A given B, and you have to calculate the rank of A given B and also rank of A. Next in step 3, you have to compare this rank value with the number of unknowns. If it is equal to number of unknowns, calculate the unique solution. If it is less than the number of unknowns, then calculate the infinite number of solutions. We will follow the same procedure for like homogeneous only, but the only difference is augmented matrix. So first for this question, write down the matrix representation. So the matrix notation is Ax equal to b. What is A? A is a coefficient matrix. So what are the coefficients we are having here? For the first equation, the coefficients are 1, 1, 1. Next for the second equation, the coefficients are 1, minus 1, 2. And the third equation, 3, 1, 1. Next capital X. Capital X is unknown variables. What are the unknowns here? X, Y, Z. So capital X is X, Y, Z. Next capital B is the constant vector. So right hand side values. Your right hand side values are 6, 5, 8. So now in step 2, step 1 is completed. We wrote the matrix representation and we identify the values of A, X, B. Now in step 2, you have to define the augmented matrix. So augmented matrix equal to A given B. So write down A given B. A is 1, 1, 1, 1 minus 1, 2, 1 minus 1, 2, 3, 1, 1. And here for difference, I am taking one line. And the last column B, you have to add for the last column of A. So B is 6, 5, 8. So this is the augmented matrix. And here you have to calculate two rank values. Now see, actually given matrix is 3 by 3 square, but after adding the matrix B as the last column of A, you are getting a rectangular matrix. You got 4 columns, 3 rows. Now what are the lower diagonal values? You fix the diagonal values. Diagonal values are 1, minus 1, 1. So below the diagonal values, see first from the starting element 2, you fix the diagonal values. Then you take the lower diagonal values. Your lower diagonal values are 1, 3, 1. Okay. So now you convert this matrix to upper triangular form. So first I'll convert the values which are in the first column to 0. That means you have to change R to R3. So the row operations are for R2, R3. Now corresponding row is R1 only, and in R1 the corresponding value is 1. So now how we can change R2? R2 is R2 minus R1. For R3, here I have 3 and here I have 1. In R1, if you are getting 3 by 3 minus 3, by subtracting you will get 0. That means the R3 row operation is R3 minus 3R1. Now what about the matrix? We are not changing first row 1, 1, 1 and this is also 6. See, whatever the row operations we are applying for matrix A, apply the same operations for B also. It is applicable for B also. So now R2 minus R1. Subtract these two rows, 1 minus 1 0, minus 1 minus 1 minus 2, 2 minus 1 1, 5 minus 6 is minus 1. Next R3 minus 3R1. What is R3? R3 is 3, 1, 1, 8, 3R1. Multiply the first row with 3. That is 3, 3, 3, 3, 6 is 18. Now by subtracting you will get 0. 1 minus 3 is again minus 2. 1 minus 3 is minus 2. 8 minus 18 is minus 10. So again if we are taking lower diagonal, still we have one more value to convert to 0. So that is R3. We have to change R3. R3 gives rise to the corresponding value is in R2, that is minus 2 only. So by subtracting R3 and R2 you will get 0. That is 1, 1, 1, 6, 0, minus 2, 1, minus 1. Now subtract these two rows, 0, minus 2 minus of minus 2 plus 2, that is also 0. Minus 2 minus 1 is minus 3. Next minus 10, minus of minus 1 is plus 1, so that is minus 9. So we got upper triangular matrix. And there is no 0 row. So if it is 0 row, it has to be at the bottom of matrix. In this case, there is no 0 row. So it's satisfying the echelon form conditions. Now you take rank for both augmented matrix and the only matrix A. So what is the rank of A given B? A given B. Rank means you have to calculate the number of non-zero rows. So augmented matrix means you have to consider this total entire matrix. So how many non-zero rows I have in this entire matrix? 1, 2, 3. So rank of A given B is 3. Similarly, rank of A. Now rank of A means you have to see only this matrix, A matrix. So in A matrix also, how many non-zero rows I have here? 1, 2, 3. Rank of A is again equal to 3. Both the ranks are equal. Rank of A given B equal to rank of A equal to 3 means the system is consistent. So if it is consistent, then we can calculate the solution also. So how we can calculate the solution? We have to identify whether the system has unique solution or infinite solutions. Again, that we can define basing on the number of unknowns. How many unknowns we have in this question? We have 3 unknowns, x, y, z. So number of unknowns are 3. Then compare the rank value. Rank of A given B is 3. Rank of A is 3. And number of unknowns are also 3. Since all these 3 are equal, then the system has unique solution. So if it has unique solution, then how we can find the solution? First you have to give justification whether it has unique solution or infinite solution. Here we got unique solution. So to find the solution, again you have to start with the matrix representation Ax equal to B. Now which value we have to choose here? Here actually A is a coefficient matrix, but instead of taking the coefficient matrix A, you have to choose the matrix which you converted to echelon form. Similarly for B also, instead of taking the initial constant vector B, you have to choose the B value from the matrix which you converted to echelon form. That means this is your A now and this is your B. So now what is A? A is 1, 1, 1, 0, minus 2, 1, 0, 0, minus 3 into x is an unknown vector x, y, z equal to B is 6, minus 1, minus 9. Now write down the equations. So what are the equations? Your first equation is 1 into x, x plus 1 into y, y plus 1 into z, z equal to 6. Next second equation 0 into x is 0, minus 2 into y minus 2y plus 1 into z is minus 1. Next third one 0, y into 0 0, minus 3 into z equal to minus 9. Now see, from the third equation clearly we got the value of z. From equation 3 we got z as minus 9 by minus 3, that is 3. Now if you are taking z in equation 2, you will get minus 2y plus 3 equal to minus 1, that is minus 2y equal to minus 4, so y equal to 2. If you are taking both y and z values in equation 1, that is x plus y is 2, z is 3 equal to 6. This is 2 plus 3, 5. If you are taking 5 to right hand side, 6 minus 5, you will get x as 1. So what is the solution? Unique solution capital X is x, y, z. That is x is 1, y is 2, z is 3. So see, I applied the same procedure, how we have done the homogeneous system of equations. In the same way, we solve the non-homogeneous also. But the only difference is in homogeneous, directly we are chasing the constant matrix and we are taking the rank for constant matrix only, coefficient matrix only. But in non-homogeneous system, you have to define the augmented matrix A given B. You have to convert that matrix to echelon form. And here you have to take rank of augmented matrix and rank of A also. If both ranks are equal, then you have to identify, you have to give justification that the system has unique or infinite solution. To find the solution, take matrix representation Ax equal to B. Substitute the values of A and B from the matrix which you converted to echelon form. Write down the equation forms. By substitutions of x, y, z in remaining equations, you will get all the values of x, y, z. So now see another problem on non-homogeneous system. So I am taking one more question. Here again we have some equations, set of equations. The given equations are 4x plus 2y minus z equal to 9, x minus y plus 3z equal to minus 4, 2x plus z equal to 1. They have given three equations with three unknowns. So do the first step. Your first step is matrix representation. The matrix notation is Ax equal to B. So what is A here? A is a coefficient matrix. The coefficients are 4, 2, minus 1. Second equation coefficients are 1, minus 1, 3. So in third equation, you are not having y term. So y coefficient you have to choose as 0. That means 2, x coefficient is 2, y coefficient is 0, z coefficient is 1. Next, capital X is unknown variables. Your unknown variables in this question are x, y, z. And capital B is a constant vector. So RHS value 9, minus 4, 1. So this is a matrix representation. Next, in step 2, you have to take the augmented matrix A given B. The augmented matrix is A given B. So that is A is 4, 2, minus 1, 1, minus 1, 3, 2, 0, 1. And B, what is B? B is 9, minus 4, 1. So we have to convert this augmented matrix to echelon form. So identify the diagonal values. Your diagonal values are from 4, diagonal values are 4, minus 1, 1. Then below diagonal means you have to convert 2, 1, 0 to 0. So first I will focus on the values which are in the first column. That means the row operations are for R2, R3. How we can change R2? The corresponding value in R1 is 4. So here we'll get 0 if you get 4 in R2. That means row operation is 4R2 minus R1. Next, here I have 2, here I have 4. There is a common multiple, 2 2s are 4. So multiply the third row with 2. Then this is 2R3 and subtract from R1. Then you will get 4, 2, minus 1, 9. 4R2. Multiply the second row with 4. That is 4, minus 4, 12, minus 16. Next, R1 is 4, 2, minus 1, 9. So by subtracting, this is 0. Minus 4 minus 2 is minus 6. 12 minus of minus 1 is plus 1. So 12 minus 1 is 13. Minus 16 minus 9 means minus 16 minus 9 is minus 25. Next, For R3, you have to take 2R3, that is 4, 0, 2, 2. Next, R1 is 4, 2, minus 1, 9. So, by subtracting again, this is 0. 0 minus 2 is minus 2. 2 minus of minus 1 plus 1, so that is 3. 2 minus 9 is minus 7. So, we have one more value to 0. You have to convert minus 2 to 0. So, again your row operation is for R3. By using R2 only, you can convert R3 to 0. The corresponding value in R2 is minus 6. So, if you are multiplying third row with 3 and subtract from second row, then you will get third row value to 0. That means the row values are 4, 2, minus 1, 9, 0, minus 6, 13, minus 25. Next, 4R3, sorry, 3R3. Multiply the third row with 3, that is 0, minus 6, 9, minus 21. R2 is 0, minus 6, 13, minus 25. So, by subtracting, you will get 0, 0. 9 minus 13 is minus 4. Minus 21, minus of minus 25 is plus 25. So, minus 21 plus 25 is 4 equal to. So, this is our matrix, and here we got upper triangular form, we got echelon form. Now, take the rank values. So, rank of A given B. Rank of A given B means for the total matrix, augmented matrix, you have to take the number of non-zero rows. How many non-zero rows I have here? 3 non-zero rows. Rank of A given B 3. Next, rank of A. Rank of A means you have to choose only the matrix A. Here also I have 3 non-zero rows. So, rank of A equal to 3. Since rank of A given B is equal to rank of A, the system has unique solution. Next, if this rank value is equal to number of unknowns, then it has unique solution. See here, if both the ranks are equal, the system is consistent. Now you have to give the justification whether it has unique or infinite solution. So here the number of unknowns are x, y, z, 3. Clearly, rank of A given B, rank of A is equal to the number of unknowns. Then the system has unique solution. System has unique solution. So now you have to find the solution. To find the solution, what we have to do? You have to take the matrix representation Ax equal to B. Take the values of A and B from the matrix which you converted to echelon form. That means this is A. A is 4, 2, minus 1, 0, minus 6, 13, 0, 0, minus 4 into capital X is X, Y, Z equal to capital B is constant vector, that is 9 minus 25, 4. Now write down the equation form. Your first equation is 4x plus 2y minus z equal to 9. Second equation is 0 into x is 0. Next, minus 6y plus 13z equal to minus 25. Next, third equation is 0, 0 minus 4z equal to 4. So we have three equations. And here also again clearly from third equation we got z value as minus 1. Now take this z value in the second equation. So I'll substitute z value in the second equation. Then this is minus 6y plus 13 into minus 1 equal to minus 25. So here we'll get minus 13. If you're taking minus 13 to right hand side, you'll get minus 25 plus 13. Minus 25 plus 13 is minus 12. Then y is equal to 2. Now substitute both z and y values in equation 1. Then this is 4x plus 2 into y is 2 minus z is minus 1 equal to 9. So here 2 2s are 4. 4 minus of minus 1 plus 1, 5. If you are taking 5 to right hand side, you will get 4x as 9 minus 5, that is 4. On both sides 4 is cancelled and you will get x as 1. So what is the solution? Capital X is x, y, z. That is x is 1, y is 2, z is minus 1. Like this you can solve the non-homogeneous system of equations. Here we are having different type of question also. Now see this question. For what values of lambda and mu for which the system 2x plus 3y plus 5z equal to 9, 7x plus 3y minus 2z equal to 8, 2x plus 3y plus lambda z equal to mu has no solution, unique solution and infinite solutions. They only gave the system has such type of solution, a different solution. Basing on that condition, you have to identify some unknown parameters in the coefficient matrix. Here the unknown parameters are lambda and mu. So you have to calculate the values of lambda and mu in this question. So first you follow the non-homogeneous procedure only. Take matrix given equation, take the matrix representation, take augmented matrix and convert augmented matrix to echelon form. So first of all, I'll write the given equations. The given equations are, first equation is 2x plus 3y plus 5z equal to 9, 7x plus 3y minus 2z equal to 8, 2x plus 3y plus lambda z equal to mu. So first you have to take the matrix representation. The matrix notation is Ax equal to B. So what is A here? A is the coefficient matrix. What are the coefficients? For the first equation, coefficients are 2, 3, 5. Second equation, the coefficients are 7, 3, minus 2. Next, for the third equation, the coefficients are 2, 3 and z coefficient is lambda. And x value. X is unknowns are x, y, z. Capital B is a constant vector. Here constants are 9, 8 and the unknown parameter mu. So how we can solve the non-homogeneous system? Clearly, since B is not equal to 0, this is a non-homogeneous system. So to solve the non-homogeneous system, we have to define one augmented matrix. So the augmented matrix is A given B, that is A matrix is 2, 3, 5, 7, 3 minus 2, 2, 3 lambda and B is 9, 8 mu. So first you have to convert this matrix to upper diagonal form, lower diagonal form, upper triangular matrix. That means you have to convert all the lower diagonal values to 0. So first I will focus on the values which are in the first column. That means row operations are for R2, R3. Here in R2 I have 7. The corresponding value in R1 is 2. So here for R2, what is the row operation? There is no common multiple between R1 and R2. So do the cross multiplication. That is for R2, here the row operation is 2R2 minus 7R1. Next for R3, in both the places I have 2. By subtracting R3 and R1, you will get R3 value as 0. The row operation is R3 minus R1. Now what about your matrix? R2, how we are changing R2? R2 is changed as 2R2 minus 7R1. First write down R1, 2, 3, 5, 9. Next 2R2. Multiply the second row with 2. That is 2 7s are 14, 2 3s are 6, minus 4, 2 8s are 16. 7R1. Multiply the first row with 7. 7 2s are 14, 7 3s are 21, 7 5s are 35, 7 9s are 63. Now by subtracting, this is 0. 6 minus 21 means that is minus 15. Minus 4 minus of minus 35 is minus 39. 16 minus 63 is 47, minus 47. Next, R3 minus R1. Just subtract third row and first row. That is 2 minus 2, 0. 3 minus 3, 0. Lambda minus 5 and mu minus 9. So now see, here we got all the lower diagonal values are 0. We got upper triangular matrix. Now we can take the rank values. But here they have given some conditions. They have given 3 conditions. If the system has no solution, you have to choose the values of lambda and mu. If the system has unique solution, you have to identify the lambda and mu. You know when the system has a no solution, when it has unique solution, when it has infinite number of solutions. First I will go with no solution. If the system has no solution. No solution means when it is possible, if rank of A given B is not equal to rank of A, then only the system is inconsistent. The system has no solution. So, before going to this rank values, first you expect what is the minimum possible rank for this case, maximum possible rank for this case. See, Rank means number of non-zero rows. When I use the word rank, you focus on the number of non-zero rows. So here totally I have 3 rows. So maximum possibility of rank is, that means maximum non-zero rows for this matrix is 3 only. So the maximum possibility for rank is 3. Minimum. Minimum means we don't know the values of lambda and mu. If lambda is 5, mu is 9, you will get 1 0 row. That means how many non-zero rows are fixed in this case? In this total augmented matrix, 2 non-zero rows are fixed. So minimum rank is 2. So when you are saying rank of A given B or rank of A, the possible ranks are either 2 or 3. So here not equal to, rank of A given B is not equal to rank of A means, so we'll get two possibilities. What are the possibilities here? Rank of A given B is not equal to rank of A is your condition. That means either rank of A given B is 2 and rank of A is 3, or rank of A is true, rank of A given B is 3 and rank of A is 2. We'll get only two possibilities. Both are not equal means the possible ranks are either 2 or 3. What is the case here? Both are not equal. Not equal means either 2 not equal to 3, 3 not equal to, any possibility we can choose here. First, I'll go with 2 not equal to 3. That means rank of A given B equal to 2. Augmented matrix rank is 2 means in this matrix we need only 2 non-zero rows. So when you will get 2 non-zero rows, if your last row is becomes a 0 row, then only you will get 2 non-zero rows. That means in this case lambda minus 5 is equal to 0 and mu minus 9 is also equal to 0. If both are equal to 0, then only you will get rank of A given B as 2. Next, rank of A is 3. Rank of A means you have to focus on this matrix up to this only. And here it is 3 means we need 3 non-zero rows. When you will get 3 non-zero rows, if this third row value is non-zero, then only you will get 3 non-zero rows. That means here we are getting another condition, lambda minus 5 not equal to 0. How it is possible? We are saying that lambda minus 5 equal to 0 for the case of rank of A given B as 2. And again you are saying that rank lambda minus 5 is not equal to 0 to get the rank of A as 3. At a time, it is not possible that lambda is 5, lambda is not equal to 5. That means rank of A is equal to 3, rank of A given B equal to 2 is fails. We are getting contradiction here. So we can't take that one. Now see the another possibility. If you are taking rank of A given B as 3 and rank of A as 2. So rank of A given B is 3. Augmented matrix rank is 3 means we need 3 non-zero rows for the augmented matrix. When you will get 3 non-zero rows, in the third row, if any one of these two value is non-zero, either lambda minus 5 or mu minus 9 is non-zero, then you will get rank of A given B as 3. That means here the condition is either lambda minus 5 is not equal to 0 or mu minus 9 is not equal to 0. Any one of these possible, then we can say that augmented matrix rank as 3. So rank of A equal to 2. Rank of A means in matrix A, we required only 2 non-zero rows. Only 2 non-zero rows means what about this value? Lambda minus 5 is must and should be equal to 0. Now by combining these two conditions give one conclusion. Here either lambda minus 5 or mu minus 9 is non-zero. In this case we are fixing lambda value. We are saying that lambda minus 5 must and should be equal to 0. So you neglect this condition and take this one, mu minus 9 not equal to 0. Then definitely the system has no solution. That means lambda is equal to 5 and mu not equal to 9. In that case, we will get a no solution for this given system. Now see the next condition. Your next condition is system has unique solution. Unique solution means what is our condition? Our condition is rank of A given B equal to rank of A is equal to number of unknowns. So how many unknowns we have here? The unknowns are 3. rank of A given B equal to rank of A equal to number of unknown means we are getting both the ranks. Rank of A given B as 3 and rank of A is also 3. That means here rank of A given B. Similarly, how we have done in the previous, in the similar way, rank of A given B equal to 3 means we need 3 non-zero rows. 3 non-zero rows are possible if any one of these two values are not equal to 0. That means either lambda minus 5 not equal to 0 or mu minus 9 is not equal to 0. Now rank of A equal to 3. Rank of A means for this matrix rank is 3 means we need 3 non-zero rows. That means here lambda minus 5 value must and should be not equal to 0. So by combining these two, if either lambda minus 5 is not equal to 0 and mu minus 9 is not equal to 0, then we can say that the system has no solution. So other case is infinite solution. So infinite solution means what is the condition? Rank of A given B equal to rank of A is less than the number of unknowns. So here we have 3 unknowns. Less than 3 means either 1 or 2. But what is the minimum possible rank for this augmented matrix? 2. That means here less than 3 means both rank of A given B equal to 2, rank of A equal to 2. So here rank of A given B equal to 2 means for the augmented matrix we require only 2 non-zero rows. When you will get 2 non-zero rows, if both lambda minus 5 and mu minus 9 are 0, then only you will get 2 non-zero rows. That means here lambda minus 5 equal to 0 and mu minus 9 equal to 0. Next, rank of A equal to 2. Rank of A means this part, only 3 by 3 matrix. The rank is 2 means we need 2 non-zero rows. That means lambda minus 5 must and should be equal to 0. So on combining, we will get the solution, infinite solution, if lambda minus 5 equal to 0 and mu minus 9 equal to 0. Like that, you can calculate some unknown parameters if the system has no solution or unique solution or infinite solution. So again, once again I'm repeating the procedure for non-homogeneous. So here the procedure is, for the given system of equations, first you have to write down the matrix representation, identify the values of A, X and B. In next step, you have to take the augmented matrix A given B and calculate the rank of A given B and rank of A. In step 3, you have to verify whether both ranks are equal or not equal. In case of not equal, there itself you can give conclusion that the system has no solution, it is inconsistent. If those two are equal, then system is consistent. Again, you have to calculate, you have to give justification that it has a unique or infinite solution. So when it has unique solution, both the ranks are must and should be equal to number of unknowns, and the system has unique solution. If both the ranks are less than the number of unknowns, then the system has infinite solutions. So to calculate the solution part, again you have to take matrix representation, choose the values of A and B from the matrix which you converted to echelon form, write the equation form. On simplification, you will get the solution, whether it is unique or infinite solution. So with this, we completed how to solve the non-homogeneous system of equations using general procedure. Later in the next session, we'll see some more methods to follow the non-homogeneous system of equations. Thank you.